Binti Noorihan, Binti Razali, and my metric number is H20A1780. I want to explain about data arrangement that given in Appendix 1. I have selected at random and MOHD and put it on table. First, I calculate class width. Formula for class width is maximum entry minus minimum entry divided by number of classes. The answer is 12.38 and round up to 12. Next is relative frequency. The formula for relative frequency is class frequency divided by sample size. The answer for relative frequency is 0.99. Last is cumulative frequency. Cumulative frequency of the last class equals sample size. To get cumulative frequency, first frequency partition second frequency and repeat until last frequency get the same as sample size, 60.
For the graph method, we have chosen frequency polygon and histogram graph. To generate a frequency polygon, we need to obtain the midpoint and frequency data. The way to get the midpoint is upper boundaries plus the lower boundaries, then divide by 2. I will give the example for the first class. 20.1 plus 32.1 equal to 52.2. After that, divide that amount by 2. Then get the midpoint, which is 26.1. After getting all the data for the midpoint of the first class to the last class, we can start plotting the graph. For the y-axis, we will plot as the frequency using the frequency data, while the x-axis will be plotted as the labor force by age group using midpoint data. The highest midpoint is in the 7th class, which is 98.15, while the highest frequency is in the 2nd class, which is 13. For the histogram graph, we need to find the upper boundaries, lower boundaries, midpoint, and the frequency. To find the lower boundaries of the first class, 20.1 must plus with 20. Then we get 40.1. After that, divide by 2. So the sum is 20.05. For the upper boundaries, we need to add 32.1 and 32.2, then divide by 2 to get the sum of 32.15. Then make the same thing for the other class. For midpoint, we just use the same method as the polygon frequency graph earlier. The lower class and the higher upper class are in the 7th class at 92.15 and 104.15 respectively. For the y-axis, we will write as the frequency using the frequency data, while the x-axis will be used as the labor force by age group using midpoint or lower boundaries or upper boundaries data.
Assalamualaikum warahmatullahi wabarakatuh. My name is NABILAH binti ZAMRI and my metric number is H20A1521 and I will explain part A, question 3. First of all, I will intro what is measures of central tendency and how to calculate it. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. First, we calculate the mean. How to calculate mean is find the sum of the values by adding them all up and then divide the sum by the number of values in the dataset. And mean from my calculation is 51.19. Next, mode. Mode is the most frequent data. Mode in my calculation is 47.9, and then median is the most centered data, and the median is 49.55. How to calculate the median is we add up all of the numbers and divide by the number of numbers in the data set. Next is measure of variation. Measure of variation is variance, standard deviation, range, and interquartile range. Variance, in my calculation, variance is 474.4518, and Therefore, the sample variance of labor force by age group in Perak 1982-2019 is about 474.4518 and the standard deviation is about 21.78191. Measure of position. The position of data value inside a data collection or its relative position in contrast to other data value is determined by the measure of position. Percentage, deciles, and quartiles are the most popular positional metric. Quartiles. Quartiles, how to calculate a quartiles? Divides data into 4 equal parts. First quartiles, 1/4 bracket n plus 1 equal 1/4 bracket 60 plus 1 equal 15.25. And third quartiles is 3/4 bracket n plus 1 bracket and then the answer is 45.75. 45.75. Next is shape of data distribution. The shape of data distribution of the labor for by age group in Perak is shown below. Mean 51.19, mode 47.9, median 49.55. This is non-symmetric bimodal distribution. And this is the bar chart for labor force by age group in Perak 1982 to 2019.
My name is Binti ALIN. Number metric is H20A15A7. This is part B data. The set of data show labor force by H 1982 until 2018. Kelantan and Melaka. Using the data show, Kelantan is X is an variable and Melaka Y is a dependence variable. The selected of the sample is 37 is N, and then this is data is taken through the internet related labor force by H 1982 and until 2018 and Kelantan Melaka. This data can be seen that Kelantan more forest working than Melaka. For example, data year 1919, Kelantan has 390.7 labor more than Melaka have 187 labor.
Hi and Assalamualaikum. My name is NURIN, ELIANA JASMEEN, Binti JOHARI. My metric number is H20A1626. This is the data that I will use to compute the person's product movement correlation coefficient. To begin, I need to add 3 more columns beside the first score and second score, which are x squared, y squared, and x times y. To find x squared, let's take a look at Kelantan. The first number we have here is 319.4. By squaring the number or multiplying it by itself, I will get 102,016.36. The same technique applies to y squared. For xy, Kelantan will be multiplied by Melaka. For example, 319.4 times 174.1, and I will get 55,607.54. So here we have sum of squares of values of variables x, which is 9,354,967.56. Next, we have sum of squares of values of variables y, which is 3,155,828.62. The sum of the product x and y is 5,422,785.69. This is the formula of Pearson's correlation coefficient. Based on the data, I will simply plug in the sums into the formula. The Pearson correlation coefficient turns out to be 0.98. Since this value is close to 1, This is an indication that X and Y are strongly positively correlated. In other words, as the value for X increased, the value for Y also increased in a highly predictable fashion.
Hi, my name is Mama Hisham NAWAWI. My metric number is H20A1244. I will present question number 3.3. There is develop the estimate regression equation. Then interpret the regression equation. By using the formula, the answer this question by using the data above, which is 18,084.8, 10,369 and 5,042,785.69 minus 37 divided by 9,354,967.66 minus 80,084.8 divided by 37, and the answer is 0.688. That's all for me. Thank you.